it's something that really started a while back as a passion project, and I hope it can be useful to all React developers, but also interesting to talk about as a React project in and of itself. It's definitely been a big source of challenges, both technical and otherwise, for us. So I'll share my screen to start going through these slides. Let me know if you can see this. Hopefully you can see this. Is that coming through?
Can you just turn off your screen share from the laptop where you have your camera?
Oh, yes, of course.
All right, perfect.
Great.
Actually, we still, oh, that's my screen share. Sorry about that. I'm gonna.
Great. Let's see. All right, so go through these slides. Basically, what is Plasmic? Plasmic is a visual builder for React, and we're working on this to solve two different problems. I'm actually curious I'm not sure if there's a way to do this with the platform, but just to poll the audience a little bit, how many folks work with Designer? Maybe if you do, just mention it in the chat. I'm always curious to know, what percentage of folks do work with the Designer. Awesome. In the meantime, I'll go ahead with my spiel here. But basically, this is one of the problems that we wanted to solve. And this is from our experience working on product teams for a long time. Building a lot of different React applications, etc. And working with designers, especially for a long time. I think most of the projects that we've worked on, we didn't get to work with a designer, but of the ones where we did, collaboration it's fun, but it can be time consuming and complex, because what happens is you have these designers who are creating these very high fidelity vector drawings, which engineers have to recreate from scratch, by hand using code, and inevitably a ton of things get missed in the translation, because it turns out that we as developers actually really are not good at catching all these rote things to translate. Or they can just be hard to translate because designs are freeform drawings. So this leads to a lot of back and forth with designers, and ultimately we have these two sources of truth that are never truly in sync, by most teams' admission. So this is what we wanted to streamline. It's just this collaboration and translation process. The second reason why we wanted to work on this was just more selfishly wanting a better and sort of rethought development process experience for those of us working on front ends. This is so we can build a lot faster, but at the same time, eliminate an entire class of visual bugs and QA and related tooling that comes with that. UI builders are nothing new. They're actually very widely used, generating perfectly fine code that ships into all sorts of major apps for a long time, but primarily on other platforms, they've seen success. So iOS, Android, Windows, where there's a clear company sort of promoting the platform, and we wanted to bring some of that to the web. So Plasmic is basically a visual UI builder that is for developers, really, but we're also trying to keep it accessible to designers, but mainly focused on developers right now, to craft complex presentational components that you can import into your existing React code base. And the idea is to let you move a lot faster and fix designer-developer collaboration. So that's a lot of words on the what and the why. I'm going to switch gears right now into a live demo. So I'm going to switch screens here. Great. So this is the tool, and it's basically an in-browser builder. So I'm going to get started by creating a new project here, and for this demo, I'm going to create a to-do MVC, which just as a refresher, very popular sort of reference app. This is what it looks like. I'm just going to create a rough subset of this. I'm not going to create the whole thing, but as I'm going through this, I'm just going to be going through it pretty quickly. So feel free to interrupt me with questions on any aspect. If I probably won't be able to keep a close eye on the chat, so please feel free to just speak up, or if somebody is able to ping me on these questions, that'd be great. This is one way you can get started is just from scratch here. I'm just going to create this this Studio MVC look and feel from scratch, but also you can alternatively start with, if you have an existing design, there's a Figma plugin that we have that can actually import designs and translate them into web standards, basically the Figma document representation. But yeah, for this demo, I'll create things from scratch. If you want to see the Figma import flow, there's actually a video of that in our website, which is, I'll just mention it now, project.app. So going back here, the way I'm going to start is I'm just going to start by drawing things on the screen very roughly and quickly, just getting ideas onto paper, not really caring about, real layout or anything like that, just absolute positioning everywhere, and creating a rough look and feel of what I'm going for. So I'm creating this task card here for the actual task itself. And inside of the task, I'm going to draw a box for the check mark, and I'm going to make that, let's say, rounded. And I'll also remove the background and give it a light border color here. Maybe that's the border color. So this is kind of the flow that we want to enable, just like very fast iteration and instant visual feedback. And rather than guessing and checking hex values or flex spaces or whatever it is in your CSS and trying to wait for a hot reload and copying values back and forth from your dev tools. Chrome DevTools, the CSS inspector is probably the closest thing that developers have to a design tool, right? But it's not quite the same. So this is really what I'm going for roughly, and maybe in here I'll also add some text for the task itself. So buy some milk. I'll make that a little bit bigger. I think it's supposed to be bigger, and I'll give it a lighter text color. Maybe I'll actually save this as a reusable text stitching. Text color, like so. Great. Okay, so that is pretty much what I want my task to look like. Now, of course, for my app, I actually want a bunch of these, not just a single one. So what I'm going to do is I'm going to create a reusable component out of this called task. And then I'm going to just, clone this a bunch of times to actually have different instances of it. I kind of roughly arrange these things vertically, but let's say I want to actually order them into a vertical list. So what I can do is, one simple way I can do that is I can lasso them into what's called a vertical stack. So I'm going to lasso them into a vertical stack, like so. And these vertical stacks basically keep everything distributed in line always. Under the hood, it's powered by Flexbox, but there's a bunch of layout controls that we try to make this thing a lot more manageable and streamlined and simpler than dealing with a lot of low-level CSS stuff directly. So what I mean by that is, for instance, I'm going to remove the background fill here, and I'm going to top align everything, left align everything. I'm going to double-click an edge to auto-size the content vertically and also horizontally. These are some of the simpler features. I'll show some more advanced features in a little bit. And I'll call this whole element task list. This is just to help my layers, basically my elements, stay organized, but at the same time, it can come in handy later for the actual code generation part, which we'll see in a little bit. So this is my set of tasks. Now, it's a little boring right now because they're all saying the exact same thing. Really want to make sure I'm buying my milk. But if I want the text to be different, in fact, I want it to be a variable, right? So what I can do is I can double click one of these component instances to drill into editing it. And this is basically, sorry, I'm gonna turn off my notifications here. 1 second. Oops. Oh, is there a way to do this? No. It's weird. I don't know why I have to go through the control panel for this, but anyway, so basically, if I double click into any one of these component instances, like here, I can edit this primary copy of the component. So any changes I make are propagated to all the instances, and maybe all I want to do for now is just take this text and I'm going to right click it and convert it into what's called a slot. And slots are basically, you can think of it as poking a hole in the component so that from outside the component from any one of these instances, I can select this and customize it. I can, a simple thing I do is just change the text. So like make to-do app show a demo. But of course, you can actually drop any elements you want, any content you want in there. It's just like a children prop in React. In fact, we call it children prop by default. So that's kind of how you build these things. It's an easy way to get component composition flexibly. So now I have these different texts. And the only other thing I want to do with this task component is, this is very common, is to design it out in its different states because components often exist in one of many states. So what I will do is I will first I'll right click this and pop it out into its own new artboard. So I can work on it in isolation. So this is just a concept where if you're familiar with React Storybook or something like that, you can work on components in isolation. And it's just an easy way to focus on one thing at a time. So the way that Plasmic models states, the concept of states and variations and things like that for components is a concept called variance. It's just this all-encompassing umbrella for all these things. So for instance, I'm going to create a group of variants called states, and maybe I want to design what it looks like when it's completed, when it's marked, when it's being edited, or when it's labeled high priority. You can design what all these look like. For this demo, I'm just going to go through this exercise of designing out the completed state. And for that, I want there to be a check mark in this checkbox. So what I would do is I'm actually going to go to this reference app. I like the look of this check mark, and so I'm just going to screen grab it real quick and paste it in here. And I'm going to zoom in to a pixel level and size it, adjust it a little bit. You can also use, of course, real layout to center things. And then that is basically what my completed task will look like. So I can switch between the two variants. So what's going on here is the completed variant is actually just a set of overrides or deltas on top of the base appearance. So to show you what's going on, I'm going to actually clone this artboard and then move it down below. So I have two views of this thing. You can create as many of these as you want, and then I'm going to have the bottom view look at the normal base appearance of the component, and then the top one looking at the completed appearance. And so any changes I make, these are not two different copies of the component, right? So if I make changes to the base appearance, they do bleed through to the completed one. But the completed one, any changes that I record specifically to that one, and you can see that we're recording to the completed state, are specific to the completed state. So the appearance of this, the check mark itself, for instance, is something that is specific to the completed state. So so that's how this system works, is basically just recording a bunch of overrides. And similarly, you can actually style anything you want in the component. So I can take this text as well and I can make it strike out, set it to be a lighter text color as well. So that's basically what I want my completed state to look like. Now, maybe another thing I care about is for there to be some another type of state that I want, for instance, some kind of interaction state, like a hover state, etc. And the thing about these variants is that you can dynamically combine any number of them at a time. So, for instance, introduce another state here, which is my my interactions, and maybe here I'll have a hover state and a press state. And so for the hover state, maybe whenever I hover over any part of this task, I want this this checkbox here to become just like darker, and also have a pointer, hand pointer, etc. So anyway, these are just things you can choose to design for all the different states and variations of a task, and then they come with the component anywhere it goes. So back in my main screen, I can select any one of these things. I can, just for the purpose of this mock, I can set this one to be completed. Maybe I can set this one to be in the hover state. Maybe I'll set this one actually to be in both the completed and the hover state. So you can see where we can dynamically combine these different variants, etc., because they're just overrides on top of the base appearance. So so there you go. And then that is pretty much it for what I want this app to look like. Maybe the final thing I'll do is add some real layout here. So I'm going to set this whole screen to be, instead of these free-floating, absolutely positioned things, I'm going to have everything flow as a column and be centered. And also, I'm going to introduce some padding to the top and bottom here, like so. And that is pretty much it. Oh, and I'll give the name for this whole screen. I'll call that a component as well. It's called the to-do app component. So I have these two components, the task component and the to-do app component. And from here, the next step is, the interesting bit, which is how do we turn this into code and actually work with it from a code base in a real way and start injecting, real behavior, et cetera, into it. One really quick and simple way to get started with that is there's an integration that Plasmic has with Code Sandbox. So you can just quickly, click and spin up a brand new, basically standalone React web app in the browser where you can quickly, dive into the code and work with it and edit it, etc. So that's one way you can get going. Oh, not sure. Oh, I think, sorry, I'm working with a development build here. And so I have to force this thing to refresh. Sorry, so this is my my development environment. Something weird is going on. I'm in the middle of some work here, but that usually works. And then, but I think the more interesting thing is being able to actually generate this into your own local code base, for instance, like this. For that, we have this CLI that you can run on some existing code base. So I'm going to show that in action. I have here running in the terminal a blank React app. So we'll clear this out actually. Great. And I'm going to show you it running, just in case you're not familiar with what a blank React app looks like. It's just a spinning logo. And so into this code base, of course, you can work with any sort of React code base. It doesn't have to be blank. I already have this client installed, so I'm going to skip the first step. But the next step after that is to run Plasmic init, which is just the first command you run every time you want to get started using Plasmic on some code base. It asks you some rudimentary questions, and then I'm just going to go with the defaults here. And the last step is to run the sync command, which is actually what pulls down the components. So we should see the two components get synced down, the to-do app and the task component. And I'll pull up my code editor on the left and have my running React app on the right. And the first thing I'll do is I'll just get everything onto the screen. So I'll replace all this boilerplate with the to-do app component. And with that, we should see that. So now we have the app that we designed exactly, running pixel perfect in the React application without writing a single line of code. Now, from here, of course, we want the real behavior and logic, the business logic and state and event handlers and whatnot, just actually wired up to these components. So I'm going to start doing that. And I'm going to click into this to-do app to drill into editing it. And from here, I can actually, so this is what the component looks like. There's a lot of comments here, but you can ignore all of these because it's just comments, just kind of explaining what's going on. But it's a really simple app, really simple component. It's just a thin wrapper around this Plasmic to-do app component, which is what actually does the rendering of the presentational crust. So all the JSX and CSS and whatnot are taken care of for you, and you just have to focus on the actual logic, the business logic. As a random example, let's say I wanted to replace these mock tasks here with some real state. So this Plasmic to-do app lets me do that because it's very flexible. It's got a very flexible interface. I can override any content, any props of any element inside of it, basically. So for instance, I'm going to create, let's say my tasks actually lived in some React state, which I'm going to define here. And let's say these tasks are, just a bunch of objects with a name property. And basically what I can do is I can reach into this Plasmic to-do app component Remember that task list element that we named earlier? I can reference that by name, and I can override any prop on it. So for instance, I want to replace all of its children with this list of tasks of my own. And to render those tasks, I'm going to use the other component that we synced down, the task component, and pass it as the children prop, the name. And so I'm going to save. And with that, we've replaced everything with the actual real set of tasks. And you can continue with this pattern of just in a lightweight way adding whatever you can. This file here, the to-do app TSX, is owned by you as a developer. We're just the Plasmic is just generating this as a starter boilerplate for you, but you can do anything you want with this file. You can replace this whole functional component with a state class-based component. You can choose not to even render the Plasmic to-do app at all. You can there's nothing magical going on with this file. It's just generating one time for you. And then the actual Plasmic to-do app is what is managed and owned by Plasmic. And this is the thing that basically is regenerated when you are updating the design. So that's basically the key property we wanted to give you in terms of the workflow. Is this is not just a one-time eject, where once you're done with the design, you eject in the code and you can start wiring up things, but then you lose the connection between the design and the code. The connection is long-lived, so you can go back into the editor and keep making updates to the design. And so that's what I want to show now. So if I go back into my terminal, I'm going to actually turn on this watch mode, which basically live streams any updates I make to the design into my code base and therefore the running React app. And so I'll have the running React app sort of sitting on the right, and I will have the editor on the left, like so. And basically, let's say I wanted to make some violent changes to the layout of this whole thing. So I'm going to actually give it more of a tiled, boxy look. So I'll select these tasks, and I'll double click into editing them, and I can start just start resizing them to be more boxy looking. And I'm then also gonna add some real layout to this thing, so everything's flowing as a row, but top aligned and maybe with some padding. And I'm also going to take this checkbox here and make it free floating and move it down to the bottom right, like so. And also I'll pin it to the bottom right, like so. Let's see, and everything is still arranged in this vertical list, but I can have everything flow as a row. But of course, this is overflowing at some point. So what I'm going to do is I'm going to turn on wrapping, so things actually wrap around. Let's see, my selection box is not refreshing, and now I can resize this a little bit and have more left-centered, instead of wrapping tiles. And now it's a little hard for me to tell the difference, tell them apart, these different tasks. So I'm also going to introduce some gap. So I'll introduce some gap in the vertical direction as well as in the horizontal direction. So things like these are just some examples of the more advanced layout capabilities that we're really trying to streamline a lot. And if you think about how to, for instance, introduce something like gaps in a cross-browser way and in a way that is amenable to wrapping, etc. It's actually kind of annoying to do in CSS in a way that doesn't end up with you fighting selector specificity, etc. So so these are all things that we really try to automate and streamline as much as possible. So you can just just find a gap in between things. So anyway, that is pretty much it. And you can see as I was making changes, they're streaming into the React code base. So this is the workflow that we wanted to enable. Now, that was pretty much it for the actual demo part of the talk. Now I'll switch gears into actually talking about going through the rest of my slides. This is the interesting bit around some of the challenges that we had in working on this. So there's a bunch of challenges, but I'll start with some of the technical ones. The first set is basically there's a lot of time spent worrying about state management and making sure that that's performant, because there's a lot of moving parts in this app, right? A lot of state, like very deep state that is reflected in a lot of ways throughout the entire surface area of the app. And so how do we consolidate that, but also make sure it's snappy to update, because you have these, for instance, these drag operations where you really want to make sure that things are smooth, right? And so that usually means you have a certain frame budget, like, you know, if you have if you're shooting for 60 frames per second, then you have a frame budget of like 16 milliseconds, which if you want to make sure you're not constantly busting that budget, then you just want to make sure that you're always doing the minimum amount of work that you need to in response to any state updates. And so just incrementally, you know, updating only the parts of the UI that you need to is important. But even beyond that, so that's more of like the latency part, but the scalability part is what makes this hard is the combination of these. So both latency and scalability. So for instance, if I zoom out here a little bit, you know, I only have these 3 artboards on the screen, but if you have, you know, hundreds of these things in a, you know, much more sprawling and complex UI that you're working on, like how do you make sure that that's, you know, something that stays snappy? Well, you know, basically for us, it came down to really making sure you are breaking up your work as much as possible into bite-sized incremental tasks that you can prioritize. So I'll show you this in action. So for instance, if I am, you know, let's say I'm selecting this artboard here, and I update, you know, I'm dragging this guy around. You can see that it is updating in the other iframes and the other artboards, actually. And I'll go into that a little bit. They're actually iframes. But you can notice a little bit of lag before they get updated. And that's because, you know, we basically are prioritizing the updates to the frame that you're actually editing the highest, and then the frames around you as the next highest priority, and then, you know, frames that are completely off screen, et cetera, are much lower priority. So basically, yeah, you just want to make sure you're not synchronously making these updates in a single, you know, single tick, but actually breaking up the work as much as you can. And you know, one thing that's going on here architecturally is that you know, this whole studio is a React application, but each of these artboards is itself also an iframe into a separate React application. So you have, like, you know, there's a total of 4 React applications that we're looking at, React TypeScript applications that we're looking at on the screen, 3 of which are being directly manipulated by the tool. And so yeah, that's kind of how things work right now. And yeah, let's see what else is there to say about this. Yeah, and of course, you know, when we do update like the position of this guy, we want to make sure we're not actually just I mean, that's actually just a style sheet update, but if we want to make other changes, you know, you only want to update the parts of the React tree that are relevant for that, and that's more, you know, traditional selective state management updating. The other technical challenge here is so there's a feature code components, which I haven't shown here, but basically it's the ability to bring in your existing, you know, for instance, you have existing code components, or you're working with the library of code components like from Ant or Bootstrap or Onsen or any one of these component libraries, and you know, you want to be able to compose UIs together from these base design systems. So that's basically what this is about, and there's a lot of moving parts to enable that as well. You know, you first of all have to be able to dynamically load this foreign code into these, you know, this canvas area, but in a way that's secure, and also, you know, accommodates all the different ways that things can be authored upstream, you know, different ways to load the styles, etc. And so that's a chunk of work in and of itself, but also this code introspection part, which is, you know, when I drop in a button or a toggle or something like that into my UI, I want to be able to configure it, right, and manipulate it. And so all the what we do is we have this tool that basically crawls your code base, finds all these components in it, you know, functional or class-based components, and then reflects out their props that they take. And from here, we basically have a bunch of heuristics to guess what are the default set of props that are most likely to be things that you want to actually manipulate in the tool. And some of these are knobs that you want to expose on the right-hand panels. But some of these, it can be a little nuanced. Like some of these props are, for instance, children props or functional children props that you want to manipulate on the canvas directly. You want to drag and drop other elements into them, etc., similar to slots. And so, so there's a lot of complexity here around just making sure we can intersect things in a high fidelity way, and still at the end of the day give you control over exactly what the knobs are that are exposed. There's a bunch of product challenges in building this thing. So one was I alluded to just making layout a lot more intuitive and streamlined, because distilling layout, like if you think about, if I just have two text divs that I want to sit side by side horizontally, and I want them to stretch horizontally to fill the available space given to them, you might try setting something like flex 1, but you may or may not be surprised at the result. Right? There's always an explanation. You can always track it down. Like for instance, in this case, flex row is something that multiplies the flex basis. And whenever you have things sitting side by side like that in flex direction row, that basis defaults to width, and width defaults to auto, which in this case means the max content size of these divs. So effectively what you have is these divs that are actually growing at different speeds depending on the text that's in them at the current time, which is crazy to me. But that's how things work in CSS by default. And so if you, this is just like a tiny example, recent example I was contending with. But if you think about like the many cuts that there's just like 10 different ways to do things in CSS, each with their own trade-offs and nuances. You may be asking yourself, why not just slap width 50% on it and call it a day? Well, you'll soon find out like the trade-offs with that. And so so that's why layout is just such a can of worms into itself, that I think really making it a nice experience working with layout, because most of the time you just want things that either stretch or wrap their content or be a fixed size, pixel or percent, and that's it. Just distill things as much as possible into that set of uniform set of sizing and layout controls, and 99% I think of the layout requirements are satisfied with that. And then for those cases where you really do need to drop down to have finer grain control, you can always do that. And then the last product challenge I'll call out here is really, I mentioned at the beginning, you can import things from other design tools like Figma. And so there's a whole set of complexity in mapping the concepts of the Figma document representation into web standards. And this involves, you can do things in Figma like have gradients a certain way, or you can have this concept of centered, like how in CSS you can have inner and outer shadows. In Figma you can have centered borders as well. And then there's things like the fact that Figma comes from more of a graphic design background means you're talking about layers and layer masks and blend modes that you can set on layers and whatnot. And these are all things that we really try to translate and do the grunge work of translating into web standards. And so just automate a bunch of that grunge work. And then from there, the main things you have to worry about are the higher level refactoring and restructuring of the component model into React component model. But I think this is probably the most interesting challenge for us, is really around our code integration teams. If you think about what is natural for visual direct manipulation and what is natural for expressing in code, we basically wanted to marry the best of both worlds and find the most flexible interface for doing so. Our goal is basically to take away the burden of keeping your code in sync with the design, but at the same time, giving you complete freedom to build and structure component code as you fit. And that freedom is important for, there's the necessary practical reasons of I just need to instrument, my element with a certain on-click handler or a certain, reflecting out my real set of tasks or things like that. But at the same time, there's what I'll call quote unquote aesthetic reasons as well. So, you want control over your own component interface, right? You don't want to necessarily, in this example here, I have these tasks that take children, and they also can take variants, etc., that I can pass in, like what state it's in, etc. But maybe this is not the interface that I want. Maybe instead of having it be fully controlled from the outside like that, maybe I actually want to pass in a higher level object like a task entry object, and then have all the have all the children and the state that that's in, etc., determined internally inside the task component from this task entry object. Just a very simple example of that. So, I want to control what the component interfaces look like. Right? I don't want this tool to dictate that for me. So the thinking is always rooted in giving you as much flexibility as possible, so that these components that you can import into your code base are always there to help and hinder. So to that end, there's actually two different, very different schemes that we that Plasmic can emit. So the first is what I've already shown. This is called the presentational library scheme, and basically, we generate for each Plasmic component. There's two components in here that are generated. There's a to-do app and the Plasmic to-do app. The Plasmic to-do app is just this inner, presentational component that handles all the rendering. The to-do app is this outer shell, this wrapper around it, and this is where you can add all the logic and behavior and state, etc. And by default, it's just a thin wrapper around the Plasmic to-do app. And so it's a very simple scheme. This is the stuff you own. This is the stuff that Plasmic owns, and then you can just pass in a very flexible set of props to override elements in it. So that's the presentational library scheme. So yeah, we basically are given this library of presentational components that you can import and run with. The other scheme is called the direct edit scheme, and this is actually very philosophically opposite of the first one, which is that we give you a direct access to a plain JSX tree that you can directly edit. And so it's a little fun to show. So I'm actually gonna switch over my this code base to from the presentational scheme to the direct edit scheme, so you can see what's going on there. Save. I'll blow everything away and start from scratch. And okay, so now, yeah, this is basically what the direct edit scheme gives you, and it gives you like direct access to the JSX tree, and so you can directly manipulate this JSX tree. So for instance, if I am let's say I want to add an on-click handler to the title here.
Hi, Yang, sorry to interrupt.
To
let you know that we've been on for about 40 minutes. It would be good if we slowly start to wrap this up.
Great.
All right.
Okay.
I'm just gonna leave you for a couple of more minutes to.
Actually, I'm gonna take this. Part doing basically, it's, imagine you basically base your there's some impact on workflow, but I think the most interesting bit is to do with the designer that basically article about you define preferences and you get a connector for um, and also just circulating visual recognition, terrain that you can use to connect your design code. think this is the most fun part, which is the thing that people are building. We actually just launched 2 weeks ago publicly. I'm not just starting for the time, and it's been quite fun. Um, I think this is the most out there thing that we've seen so far is honestly a whole library of sensors, and of course, Plasma itself is built in Plasma. We have to show you the Plasma kit that has all these various
Hi, Yang. Sorry, I think I accidentally managed to turn off your voice. If you click the microphone button, you should come back on. We've been having some technical issues, so we couldn't hear you properly.
Oh yeah, sorry, I don't know
perfect now.
where things left off, but I think the RackJet scheme. I was just saying I'll skip that for now. I'll show you that later, and then the impact on the workflow. I think the most interesting thing about this is if you work with designers, then you can you can invite them into the workflow, and there's something magical about if you do a Plasmic sync and you have a nicer version of your landing page appearing in your code base when you sync, for instance. And the fact that we can eliminate visual regression tests, manual queuing of lining up your designs with your code, etc. I think this is the most fun part, which is that we actually just publicly announced this project 2 weeks ago. And so we've been getting a lot of users, and it's been really fun actually seeing what people are building. I think this is the most crazy thing, which is a control panel for LiDAR sensors on autonomous vehicles. Yeah, and then Plasmic itself is also built in Plasmic as well. So I was just saying that all these various parts of the Chrome, the left bar, the top bar, the actual code sandbox and share dialogue and these right panels, they're all built in Plasmic. So you have a Plasmic design for these things. And that's pretty much it. So thank you for listening, and definitely welcome your playtesting. We'd love to get your feedback on the tool end to end. Yeah, thank you.
All right, that's been perfect, Yang. Really interesting talk. I really like that, like bi-directional connection, like that I did not see any other tool has. We have, I think, 2 questions, but because we've been we used more than 40 minutes, 45 minutes for this talk. I'd like to just go take a quick break for about 10 minutes. Yang, you can take the top left table, and anyone who, and anyone who has questions, just pop into that table, and you can repeat your question from Q&A section that you asked.
Awesome. Yeah, thank you.
Yeah, thank you, Yang, very much. That was like really interesting. And see you all in the table view.
All right, I'm popping in.